Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Hope you and your family in the best of health. Dear students, this lecture is for grade 8, boys and girls, both wings. Subject chemistry, chapter number 3, periodic table and periodicity of properties. This is my 20th lecture, and I am your lecturer, Mrs. Saira Jamal. In this lecture, we are going to discuss shielding effect, which is very important topic. What is meant by shielding effect? The reduction in force of attraction between the nucleus and the valence electrons or outermost electrons by the electrons present in the inner subshell is called shielding effect. The decrease in force of attraction between the nucleus and outermost electrons due to the presence of electrons in the inner shells is called shielding effect. Variation of shielding effect. Variation means what happened to shielding effect when we move from top to bottom along group or when we move from left to right along the period. First of all, we will discuss variation of shielding effect along group. Shielding effect increases from top to bottom along group. Why shielding effect increases from top to bottom along group? Reason is as we move from top to bottom along group, the number of electronic shell increases. Number of electronic shell means the number of shells increases. When we move from top to bottom, the number of shells increases, so the number of electrons in the inner shell also increases. As a result, the shielding effect increases. Let us take the example of rubidium. Rubidium is present in group number 1. Lithium, sodium, potassium and rubidium, they are present in group number 1, and when we move from top to bottom, from lithium to rubidium, you can see that the number of shells increases. Lithium is present in second period because it has 2 shells, and I told you that the shell number actually decide the period number. So lithium has 2 shells, it is present in second period. Sodium has 3 shells, it is present in third period, potassium in fourth period, and rubidium in fifth period. Now the number of electrons in the inner shell. This is the outermost shell, and the shells which are closer to the nucleus are called inner shell. In case of lithium, only one inner shell is present. In case of sodium, 2 inner shells are present. In case of potassium, 3 inner shells are present. In case of rubidium, 4 inner shells are present. So greater the number of inner shell, definitely greater will be the number of electrons, inner electrons. You can see only 2 inner electrons are present in lithium, then 2 in the first shell and 8 in the second. So 2 plus 8, 10 inner electrons are present in sodium, and 2 in the first shell, 8 in the second shell and 8 in the third shell. Total, how many inner electrons are present? 18 inner electrons are present in potassium. And atomic number of rubidium. Atomic number of rubidium is 37. So 36 inner electrons are present in case of rubidium. So from top to bottom along the group, due to the addition of a new shell, the number of shell increases as well as the number of electrons in the inner shell also increases. So greater number of shells, greater number of inner electrons, greater will be the shielding effect. That's why rubidium has greater shielding effect than potassium. Potassium has greater shielding effect than sodium, and sodium in turn has greater shielding effect than lithium. Variation of shielding effect in a period. Period, I know I told you that the horizontal rows in periodic table are called period, and when you move from left to right in a period, the shielding effect remain constant. Why shielding effect remain constant? Reason is that excuse me, a long period shell remains constant. Like along the period means that all the elements which are present in same period, they have same shells. So all the elements which are present in second period, they have 2 shells. All the elements which are present in third period, they have three shells, so on and so forth. So a long period, the shell remains constant. So the number of electrons in the inner shell always remains constant. Greater the number of inner electrons, constant the number of inner electrons, constant the number of shell. So constant will be the shielding effect. So shielding effect remain constant from left to right along the period. For example, if we take the example of lithium and beryllium, lithium is present in group number 1 and beryllium is present in group number 2. So when we move from left to right along the period from lithium to beryllium, what happened? The number of shells remain constant. Two shells are present in lithium and two shells are present in beryllium. So shell numbers are same. And the number of inner electrons, two inner electrons are present in case of lithium and two inner electrons are present in case of beryllium. So number of shells are constant, number of inner electrons are constant, although the number of electrons in the outermost shells are different, one in case of lithium and two in case of beryllium. But the number of inner electrons are constant and the number of shells are constant. So constant number of inner electrons, constant number of shell, so shielding effect will also remains constant. Example 3.5, choose the elements whose atoms you expect to have greater shielding effect. The first case is beryllium or magnesium and second case is carbon or silicon. So beryllium and magnesium, they are present in group number 2A of the periodic table, while carbon or silicon are present in uh, group 4 of the periodic table. First is beryllium and magnesium. Beryllium and magnesium, I told you, are present in group number 2 of the periodic table. Beryllium is present in the second period and magnesium is present in the third period. So beryllium has two shells while magnesium has three shells. And I told you greater the number of shells, greater will be the shielding effect. So magnesium has greater shielding effect and beryllium has a smaller shielding effect. Then carbon and silicon, they are present in group number 4 or we can also call it 14 of the periodic table. So carbon is present in second period, it has two shells and silicon is present in the third period, it has three shells. So again, and greater the number of shells, greater will be the number of inner electrons and greater will be the shielding effect. So silicon has greater shielding effect. So in this case, magnesium will have greater shielding effect, while in this case, silicon will have greater shielding effect. And the reason is look at the periodic table and find the relative position of given elements in the periodic table. I told you their position in the periodic table. Position of beryllium and magnesium are group number 2, period number 2 for beryllium and period number 3 for magnesium. Carbon or silicon belong to group number 4, carbon to belong to second period and silicon belong to the third period. That is called position. Means what is the group number, what is the period number. So it is called position of the given element. Apply the trend of increasing shielding effect in group, and trend in shielding effect along the group is that along the group shielding effect increases. Self-assessment exercise 3.5. Choose the elements whose atoms you expect to have smaller shielding effect. First case is fluorine or chlorine, lithium or sodium, boron or aluminum. The first case is fluorine or chlorine. So fluorine and chlorine both are present in group number 7 or also called group number 17 of the periodic table, but they are present in the same group. Fluorine is present in second period and chlorine is present in third period. Fluorine has two shells and chlorine has three shells. So greater the number of shells, greater will be the inner electron and greater will be the shielding effect. But as they ask about the smaller shielding effect, so fluorine has smaller shielding effect in this case because it has only two shells. Second case is lithium or sodium. Lithium and sodium, they are present in group number 1A. Both are present in the same group, but lithium is present in period number 2, so it has two shells, and sodium is present in period number 3, it has three shells. So definitely lesser number of shell means smaller shielding effect. So lithium has smaller shielding effect. Third case is for boron or aluminum. Boron or aluminum are present in group number 3A or also called 13. And again, boron is present in period number 2. It has 2 shells. And aluminum is present in period number 3. It has 3 shells. So boron has 2 shells. Two shell means 2 electrons are the inner electrons. But aluminum has 3 shells, so 10 electrons are the inner electrons. Greater the number of shells, greater will be the number of inner electrons, and hence greater will be the shielding effect. And the smaller one is for boron. And as they ask about the smaller shielding effect, so in first case fluorine, second case lithium, and third case boron has smaller shielding effect. The reason is that they are located at the top position of their respective group. They have smaller size than other due to lesser number of electronic shell. Therefore, a lesser number of electronic shell means lesser will be the number of inner electrons, and hence lesser or smaller will be the shielding effect. Coming towards the next topic, that is properties of elements. The properties of elements, if they are physical properties or if they are chemical properties, these properties depend on the electronic configuration of the atoms. And now we will discuss some important properties, like 4 important properties of atoms that are influenced by the electronic configuration, or in other words, you can say by shielding effect. Those 4 important properties are atomic size, ionization energy, electron affinity, and electronegativity. These properties are periodic, they repeated in a proper manner, and they generally increases and decreases in repeating manner through the periodic table. Repeating manner, I told you about periodicity of properties, like these properties are repeated at regular interval. First property, which is affected by shielding effect or the electronic configuration, is atomic size. What is atomic size? The size of an atom is the average distance between the nucleus of an atom and the outermost electronic shell, or the distance from the center of the nucleus to the outermost shell of electrons in the atom of an element is called atomic radius. So atomic shell or atomic radius, they are, or atomic size or atomic radius, they are same. You can see that the distance or is the distance between the nucleus and the outermost electron is called atomic radius. And you know, this also you can call it the radius of a circle, because you know that orbits are circular in form. So distance between the nucleus and the outermost electron is called atomic radius. Then variation in atomic radius or trends in atomic radii along period. When we move from left to right, what happened to the atomic radius? When we move from left to right along the period, atomic radius decreases. Why atomic radius decreases? The reason is that when we move from left to right, or from one element to the next, toward the right side in the period, what happened? Another electron is added to the same shell, because in same period the number of shell remain constant. Only with increasing atomic number the number of electron and proton increases. So that's why the positive charge on nucleus increases by 1, means 1 proton added in the nucleus. So that proton will be attracted by the will attract the electrons which added in the outermost shell more strongly, and due to that stronger attraction between the nucleus and the outermost electron, the size of an atom decreases, or the radius of an atom decreases. For example, in going from lithium to beryllium, the atomic radius decreases. From lithium to beryllium, you can see in this image, lithium to beryllium, and then onward along the period, the size of an atom decreases, or atomic radius decreases. The value of the radii: 152, 112, 85, 77. This is exceptional: 70, 73, 72, and 70. So you can see that when you move from left to right along the period, the atomic radius decreases. And I told you the reason why atomic radius decreases. Although the shells are constant, but due to increasing atomic number, the number of proton increases in the nucleus. So you can say positive charge increases on nucleus, so that more proton will attract the electron more towards themselves, As a result, the size of an atom will decrease. But from we can also understand this from the valence shell configuration. Both have two shell lithium and two shells in beryllium, but one electron is present in lithium and two electrons are present in the outermost shell of beryllium. So more electron means more attraction of the nucleus on the electron, and as a result, the size of the atom will decreases. So when we move from left to right, the size of the atom decreases due to the stronger force of attraction between the nucleus and outermost electrons. Next is the general trend or variation in atomic radii along the group. What happened to the radius when we move from top to bottom along the group? Generally, atomic radii increases from top to bottom along the group. Why atomic radii increases? The reason is that when due to the addition of new shells. Because I told you in the second period, two shells are present, in third period, three shells, four, five, six, so on and so forth. When we move from top to bottom along the group, the number of shells increases. Greater the number of shells, greater will be the size of the atom or atomic radii. Example is sodium atomic size is greater than lithium. As I told you, lithium, sodium, potassium, and rubidium, these are all the elements which are present in the same group 1A. And you can see that rubidium has greater atomic size than potassium, sodium, and sodium has greater atomic size than lithium. And the reason is simply due to the addition of new shells. Lithium has two shells, three shells, four shells, and five shells. So greater the number of shells, greater will be the atomic size or ionic radius. Example 3.6, choose the element whose atom you expect to have greater atomic radius in each of the following pairs. First pair is magnesium or aluminum, second is carbon or silicon. And we have to find out greater atomic radius. Let us see magnesium or aluminum. Magnesium or aluminum, if you see, magnesium is present in group number 2 and aluminum is present in group number 3. And I told you when we move from left to right along the period, atomic radius decreases. It means magnesium has greater atomic radius than aluminum. And second is carbon and silicon. Carbon and silicon both are present in group number 14 or 4A of the periodic table. And carbon has two shells and silicon has three shells. So definitely greater the number of shells, greater will be the atomic radius. So from checking their position in the periodic table, you can say that the large atom in first case is magnesium, and in second case the large atom is silicon. And over here they say that where those elements are present which have greater atomic radius, so they say that further to the left in the periodic table, at left side of the periodic table are larger atomic radii element, and group lies closer to the bottom, and at the left bottom of the periodic table most of the elements are present which have greater size. So magnesium in the first case and silicon in the second case is a larger atomic uh, they have larger atomic size or greater atomic size or radius. Self-assessment exercise 3.6 using the periodic table, but without looking at the figure 3.3, choose the element whose atom you expect to have smaller atomic radius in each of the following pairs. Oxygen or sulfur, or second is oxygen or fluorine. So oxygen or sulfur or oxygen or fluorine. First is oxygen or sulfur. Oxygen or sulfur. Oxygen and sulfur both are present in group number 6 of the periodic table, also called group number 16. And oxygen is present in the second period and sulfur in third period. So sulfur has more shells, 3 shells, and oxygen has 2 shells. Definitely atomic size of sulfur will be greater than oxygen. And second case is oxygen or fluorine. So oxygen is present in group number 6 and fluorine is present in group number 7 or 16 and 17. And if you remember, I told you when we move from left to right along the period, so atomic radius decreases. It means fluorine has smaller atomic radius than oxygen. Although both are present in the same period, but due to the greater number of proton and greater nuclear charge, they have greater atomic radius. So in first case, oxygen, smaller atom is oxygen because atomic radius increases in moving from top to bottom. While in second case, fluorine has smaller atomic radius as atomic radius decreases gradually in moving from left to right in a period. When we move from left to right in a period, then atomic radius decreases. Next important topic is about the ionization energy. What is ionization energy? The minimum amount of energy required to remove the electron from the outermost shell of an isolated gaseous atom is called ionization energy. Isolated gaseous atom means that like the atom is free, it is not in the molecular form. That is called isolated gaseous atom. And the energy which is required to remove electron from the outermost shell is called ionization energy. You can see that if M is any metal and if we provide energy to that atom, what will happen? It will loses electrons and will convert it into the cation form. So this type of energy which is required to remove electron from this M is called ionization energy. Explanation: ionization energy value is high. If a very high value of ionization energy means that there is very stronger attractive forces between the nucleus and the outermost electron. But very low ionization energy definitely will indicate weak attraction between the nucleus and the outermost electron. Stronger attraction means it will be difficult to remove electron from the outermost shell of the isolated gaseous atom. The reason is that those electrons are strongly pulled by the nucleus. Unit of ionization energy is kilojoule per mole, and then variation in ionization energy along the group. Ionization energy values decreases from top to bottom in a group. Why it decreases? This is because the shielding effect increases. More shell means the outermost electrons are less attracted by the nucleus, and it is easy to remove the electron from the outermost shell because attraction of the nucleus on that electron is weak. So by providing only little energy, electron can easily be removed from the outermost shell. From top to bottom, due to the weaker attraction of the nucleus on the outermost electron, ionization energy decreases. It means less energy is required or less energy will be required to remove electron from the outermost shell of that atom. So they are easy to remove. This lead to a decrease in the ionization energy from top to bottom in a group. And then, for example, you can see group number one element, lithium, sodium, potassium, rubidium, and cesium. You can see ionization energy 520, 496, 419, 403, and then 377. So when we move from top to bottom along a group, ionization energy decreases, which is 377 in case of the first group. Variation in ionization energy along the period. When we move from left to right in a period, ionization energy increases. Why ionization energy increases? As we move from left to right in a period, the shielding effect remains constant, but we discussed that the nuclear charge increases. Nuclear charge means the number of protons in nucleus increases progressively. A stronger force of attraction between the nucleus and the valence electron increases. More electron, more proton, more attraction. This lead to increase in ionization energy from left to right in the period. And I told you more attraction means smaller will be the size of atom, smaller size means more attraction of nucleus on the outermost electron. And then to remove electron from the outermost shell, a very large amount of energy will be required. So hence we can say that ionization energy will increases when you move from left to right. You can see in this case, this is second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. So the maximum ionization energy is for fluorine, which is 1681, and the lowest is for lithium, which is 520 kilojoule per mole. So it means when we move from left to right in a period, ionization energy increases. Ionization energy increases mean that more energy will be required to remove electron from the outermost shell of fluorine, and the reason is a smaller size, greater nuclear charge, and greater attraction of nucleus on the outermost electrons. Example 3.7, choose the element whose atom you expect to have smaller ionization energy in each of the following pairs: boron or carbon, nitrogen, phosphorus. Boron and carbon. Boron is present in group number 3, carbon in group number 4. So when we move from left to right along the period, I told you that ionization energy increases. So carbon will have more ionization energy than boron. Nitrogen and phosphorus belong to the same group. So nitrogen is present in period number 2 and phosphorus in 3. So size of phosphorus is greater than nitrogen. Greater size, lesser will be the attraction of the nucleus on the outermost electron, and little energy will be provided to remove electron from the outermost shell of phosphorus. So smaller ionization energy in the first case is for the boron, and in the second case the smaller ionization energy is for the phosphorus. So this is example 3.7. Then self-assessment exercise 3.7. Which atom has the smaller ionization energy, boron or nitrogen? The atom with smaller ionization energy is boron, because boron is present in group number 3 and nitrogen is present in group number 5. So ionization energy decreases from left to right. So, sorry, ionization energy increases from left to right. Nitrogen has smaller sizes, more attraction of nucleus on the outer electron, and more energy will be required to remove electron from nitrogen. So boron has smaller ionization energy. In this case, beryllium has smaller ion, beryllium or magnesium. Beryllium is present in second period and magnesium in third period. So magnesium has greater size, smaller ionization energy. Carbon or silicon, silicon has greater size and smaller ionization energy. These two are along the group, and this one is along the period. So along the period, ionization energy increases, and along the group, ionization energy decreases. So dear students, are all about the today's topic, and hope you understand it. For till the next lecture, take care. Allah.